It's 6, lesson 8. So transformations, part 2. So now we're taking sine and cosine. We just talked about amplitude and period change, and now we're talking about phase shifts and vertical displacement. That simply means graphs moving left and right, up and down. Okay, so stuff we've already done before. So again, just intuitively, what do you think this one does? Maya, what does this one do, you think? Yeah. It's okay. Yep, right 30. That's all it means, right? Hey, Jake, what do you think the second one does? Up 2, correct. Okay. Brooklyn, 3. Down 1, yeah. And the last one, we just got to move the 45 over, but it's right 45, and then up 45. Okay, so all the stuff that we kind of expected it would be. Okay, and so in trigonometry, it says that horizontal translation is referred to as a horizontal phase shift. Okay, and then a vertical translation is called vertical displacement. Okay, I think the thing to make sure you guys understand, when you guys move stuff up and down, you know how that x-axis is a symmetry line usually? Your symmetry line moves, because now that thing cutting that graph in half is where you moved it. So like if you move it up, the thing is cutting in half now. Like if you moved it up 3, the thing cutting in half now is 3. So don't, like that kind of helps you with your amplitude. You want to count from there for your amplitude, or depending where it's centered, is my point. So, okay, so let's go and do this here. So this gives a couple examples. So we know that sine x is no phase shift and no displacement. The second one, phase shift is right pi over 4. No vertical on that one. Second one, there's no phase shift, but there's an up 5 for vertical displacement. Horizontal phase shift for the fourth section there is left 3 pi over 2. And then we're going to go down pi. Now pi is still a value, so don't get confused in terms of, radians there. That's a 3.14 movement. And so simply, in terms of definition, we're going right C, up D, right C, up D. So right here, this is just illustrating that thing that we had to do earlier. Don't forget, you got to pull out a number if you can to see what the shift is, right? So if they have something in common, you pull that out to see the horizontal stretch, and that will show you the phase shift, okay? Just like we did before when we were doing translation stuff. Okay, and then it says again, would you expect cosine to act similarly? Yes, it does. And so now we're just going to summarize these things. Okay, thank you. All right, summarize. So in summary, okay, so C refers to our phase shift. If our phase shift, we go to the right when C is bigger. Now remember, this is thinking opposite because it says minus C. So just remember that they talk about it in a flipped way. We just know that once we see a minus, we think move right. When we see a plus, move left. That's kind of how we think about it. Vertical displacement, just move normal. When your D is bigger than 0, you move up. When your D is less than 0, you move down. Okay, your vertical displacement can be determined by your max plus your min divided by 2. That can tell you where you're at. Okay. Summary of effects. So again, talking about sine and cosine. Amplitude still max of minus min divided by 2. Period still 360 or 2 pi divided by b. Horizontal phase shift, again, is if it's you see the plus, you move left. You see the minus, you move right. Vertical displacement, up if you're positive, down if you're negative. Okay. Everything's the same for tangent. We already talked about the last two, so I won't go over those again. But tangent has the same thing. Tangent, you can move the phase shifts, so they still move, positive move left, negative move right. Vertical displacement, they can also move vertically. They can move up and they can move down. So their change is the same. Okay. All right, so let's look at these here. Consider equations in the form of sine there and cosine, where a is 1 and b is 1. Write the equation that represents a cosine function have a horizontal phase shift of 75 degrees right. So we're going to write cosine. So they told me a is 1, okay, so that's cool. So cosine, and then we want move to the right, so x minus 75. Degrees, yeah. 75 degrees, you put it, that's fine. Not with me, no, not for me, yeah. Just got to be in the right mode in your calculator and that kind of stuff. But sine function having horizontal phase shift of 3 pi over 5 radians to the left. So sine and displacement 4 units up. So sine left, so that means plus. So x plus 3 pi over 5, and then plus 4 on the end. Okay. All right, we're going to just leave it here for example 4. I'll try to squeeze it in, but find the amplitude, period, horizontal phase shift, and vertical displacement of all the graphs. So it doesn't say to do the reflections. The ones on part B have reflections for the next two, but it doesn't ask for that, so you don't have to state it. But it says amplitude to period. So I have a 3 here, so it's going to be 1/3 of 2 pi. So period 2 pi over 3. My horizontal phase shift is HPS is left pi. And then my vertical displacement is down 4. So that's everything they asked for there. Part B, amplitude 2/3. Remember, don't worry about the negative. It doesn't ask for reflections right now. Your period is 1/4, so that means 4 times 2 pi. So your period's 8 pi here. It's a big one. Your horizontal phase shift is right pi over 12. And your vertical displacement is up 3. Okay, any questions? Yeah. The periods? So remember, the periods is this number flipped times by 2 pi. So that's 3, 1/3 times 2 pi is 2/3 pi. This one, flip 1/4 is 4. 4 times 2 pi is 8 pi. Yeah. Any other questions? Good? Okay. So then we're doing the same thing for the next section here. Find the amplitude, period, horizontal phase shift, the following graphs. So same thing. So this says, this one's, so amplitude 2. This time, what are they doing to you here? Making you pull the 3 out. So we're going to pull the 3 out and make it pi over 3 here. So that means my period, again, is 2 pi over 3, just like last time. And it's my horizontal phase shift is left pi over 3. And my vertical displacement is down 3. Oh, 4, sorry. Thanks. Got too much in a rhythm there. Okay, so down 4. Okay, for B, the cosine there, that there's no amplitude, just 1. Okay, it is flipped, but again, they're not asking for that. Pull a 2 out here. Remember, half of a half is a fourth. It's a fourth. I wrote half, but it's a fourth. Half of a half is a fourth, so it's x minus pi over 4 there now. So amplitude 1, I pulled a 2 out, so that means my period is going to be 1/2 of 2 pi, which is pi. I'm going right, so my horizontal phase shift, right pi over 4. And my vertical displacement, up pi. Okay, any questions on that one? So it says compare those four we just did, like the A to A and B to B, and the comparison is the only thing different is the phase shift. Okay, so they have the same amplitudes, they have the same displacements. The only thing different was the phase shift for part C there. All right, so now we're going to look at some graphs, and we're going to go ahead and get these narrowed down to an actual graph. So this first one we're looking at is a sine. So again, it's important to point out the scale here and how they're getting the scale. It was kind of confusing for last class, so let me kind of help you. So it's 3 to get to pi over 2, which is kind of a hard thing to think about. But that means pi over 2. If you took a third of pi over 2, what would that be? Pi over 6. Good. Now look, this is like I did in the video for the unit circle. Pi over 6, 2 pi over 6. 2 pi over 6 is a third. 3 pi over 6, half. 4 pi over 6, 5 pi over 6, 6 pi over 6. So essentially this thing is going by 6 pi over 6. Okay? So that's how this graph is going. All right, so now we have that established. So it says the equation of the graph form y equals a sine x minus c if a is positive and there's a minimum possible horizontal phase shift. So what it means by minimum possible phase shift is that obviously they're continuous, so they want to take the one that's closest to the y-axis. So if this is a sine graph, we want to pick up right here, right? And so the one that's closest to the y-axis is this phase shift. Does that make sense? It says a minimum phase shift. Because obviously there could be infinite amount of answers if they didn't say minimum, right? So since it's minimum, we go there. So first thing is, if it moved over 2 blocks, what's 2 blocks? We just talked about that. Pi over 3, yeah. Okay, pi over 3, 2 pi over 6. Okay, so it's pi over 3 is the phase shift. And it moved to the right, so we have a minus. So that means sine of x minus pi over 3. So we have there. What's A? 4, right? 4 is my amplitude. And that's all you have here. There's no vertical displacement. Okay, any questions on that? You can write 2 pi over 6 if you want, but I mean, pi over 3 is what it will be. Like in the answers you see, they'll always reduce, because 2 over 6 is pi over 3. Okay. Questions? Okay, so that's all for that one. Okay, let's look at the next one here. So again, it's another sine graph. So write the equation of the graph in the form of, same thing we just did, and find the minimum possible horizontal phase shift. So again, for minimum possible horizontal phase shift, for part B here, so sine, but here's the difference. It said my A is negative. So instead of sine starting going up, sine should start going down. So we actually want this guy, because if sine was flipped, it'd go here first. So this is the sine curve we're looking for. Does that make sense? It still is 4, right? It's still 4. And so what changes is it's going to be plus, now you count your 6 again, 1, 2, 3, 4. So 4 over 6 is 2 pi over 3. So it's plus 2 pi over 3 in this case. It is not a coincidence that 2 pi over 3 plus pi over 3 is 1. Because every pi is when they change signs, right? So when you're at sine changes sign every, I don't like saying that, changes every 180 degrees. Because sine's positive on top, negative on bottom. Cosine's negative on the 180 right, positive on the 180 right, negative on the 180 left. So they change every pi is my point for the sine. Okay, that's it for that one. Sorry, it was flipped, so we do put negative 4. Okay, cool. All right, now let's look at the cosine one. Write the equation of the cosine graph where A is positive. So cosine starts at 1. So that means cosine graph we want is right here. That's the one that's closest for a phase shift, right here. You see that? Because cosine starts at 1. Because the x value at 0 is 1, so cosine starts high. Okay? So that means this one again, it's 4. They're keeping the amplitude consistent for you. And it's going to be x minus, because it moved to the right, where's that at? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So it's minus 5 pi over 6. Questions with that? Good. Okay, same game. Your a is now negative, so they're flipping it on you. So now you have to think instead of cosine starting high, it started low. So the difference with this one is that remember, you got to pay attention to the closest, because it could be here or here, but which one's closest to the y-axis? This one is. So the point is, guys, that these are repeated. So like, there's a lot of different ways you can write these graphs that'll land right on each other, but they're given specific instruction to find the one closest to the y-axis for phase shift. So like if you're doing a phase shift, a really big phase shift, like a phase shift bigger than like 2 pi, or actually bigger than pi over 2, you probably got the wrong one. Okay, so this one's simply just one box to the left, yeah? So that's just what? Cosine x plus pi over 6. 1/6, just 1. And then it's a negative 4, because they said that our a is less than 0. Okay, questions there? Okay, so we got one more page and one example, one little example at the end. Okay, we're almost there. Thanks for toughing it through. All right, so consider the graph shown. If the graph represents a sine function, so I missed this last class. I didn't see the sine word there. To see it with you guys is good. So it's sine. So we know we're concentrating on sine. Where a is greater than 0, complete the table and write the equation represented by the graph. So you can see clearly the x-axis is no longer my center line. You guys see that? So you can see that looks like -2 is my center line now. In terms of that's the symmetry from top to bottom. Okay, you can still do the same stuff though. By definition, if you go 1 minus a -5, what's 1 minus -5? 6. And what's 6 divided by 2? 3. So you still get your amplitudes fine. That part's not any different. So your amplitude's 3. But you can also count from the center line. You can see that it's 3. Okay, now it is a cosine graph. So, or sorry, sine graph. Sine here to here. That's one full turn, right? From this dot, let's change color here. From this dot to this dot. That's a full period of sine graph. So what does that happen in? Well, again, so they changed it on you. Kind of made us mad last class. It's now not going by pi over 6. It's going by, who knows? Who's good with fractions? Pi over 3. 1, 2, 3, right? Pi over 3, 2 pi over 3, 3 pi over 3. It's going by pi over 3 now. Okay, so a period is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is 12 divided by 3? The period's 4 pi. Right? Does that make sense? And guys, you can kind of see that. Let's cheat just a little bit. I don't condone cheating, but see right here? That line's 4 pi. That's 1 away. I'm 1 away from the y-axis. I just moved 1 over. So you can kind of see it's 4 pi just by going over 2. Okay. What's our phase shift then? Our phase shift is left pi over 3, right? Just 1 square. And then we know that it moved down 2 for vertical displacement. Okay, so if we finish this and write the equation, that's what it asked me to do here for B. I'm just going to write it right below. Oh, sorry. We're writing the equation of this, and then we're going to do an equation when it's negative. So it's y equals 3 sine. Period's 4 pi, so I want 1/2. And then I want x minus pi over, plus pi over 3. And then I want minus 2. So there's my equation. Any questions on that? Putting that all together. So 3 in the front, my amplitude, 1/2, because I'm doubling, flipping, and multiplying to 2 pi. Left pi over 3, so plus pi over 3, and then down 2 for my vertical displacement. So here's the thing that's interesting. Okay, again, you guys get a little bit better notes here, because if you flip this, if you said your amplitude was negative, where would you now be looking for your graph from? So if you said your amplitude was negative, so right, and so if it's a positive sign, its first move is to go up. Right, and so, and it says, does it say down there? Let's see. Write the equation of the graph that represents, so represents the graph when it's going to be flipped. So my point is that I actually want to start here when sign starts to go down. What's that? Start here? You can. I think this one's farther though, and this one's a little closer, so I guess they went with the right one. But that would still be technically right, Jake, but you would want to know, like if you're doing a test, that what you have is equal to the other one. You know what I'm saying? So, but yeah, you're still good. So the point is, guys, is that it'd be the same exact graph. So if I, for part B here, it'd be y equals -3 sine. It's still 1/2. The only thing that's going to change is going to be x. So I count this here. 1, 2, 3, 4, 5. So 5 pi over 3 is what the movement is, and it's still -2. So if you had a negative amplitude, or not amplitude, a reflection, okay, that's what would change. Okay. Okay, now let's look at one for cosine. Is everybody okay? Besides worn out, everybody's all right? Okay, we're done here. You guys are gonna have actually a lot more time. All right, so if the graph represents a cosine function where a is greater than 0, complete the table, write the equation represented by the graph. All right, so what is the amplitude? Looks like they gave us the same center line, huh? Same center line, so what's my amplitude? Still 3. Not very creative. Okay, what's my period? So you can get it from anywhere. I think I'm going to go right here to here. It's going by thirds again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a 12 again. Again, not very. Okay, again, you can look at that again, like Stella and Jake last time. This one's 2 over. Here's 4 pi. It's 2 over 4 pi. So you can see that that's 4 pi distance. Minimum horizontal phase shift. So horizontal phase shift is right 2 pi over 3. Right, 2/3. And that's still down 2 for the vertical displacement. All right, so my equation is that. Okay, and let's flip it on you, and let's go for the negative piece. And this time, so Jake, we probably go from this one this time, because that's closer to the y-axis. You guys see that? So we're going to start here, because this is like our -1, right? Or our negative portion of the cosine graph. So we're going to start here because it's flipped. And so all we're getting that's different is we're just looking at the phase shift. 1/3, 2/3, 3/3, 4/3. So it's going to be the same exact graph. I'm doing part D here. It's the same exact graph, except for -3 is my amplitude. I still have the same period, but my phase shift changes to +4/3. And then the -2. That's all it changes for the negative there. All right, any questions? If you still care? All right, last little piece here. Okay. Consider the graphs of function a and cosine, so it's a and cosine, changing which parameters a, b, and c, d affect the domain. So when is the domain affected? Okay, that affects like the stretch and stuff, but does that affect what you can use for x? So there's no problems with x as the point. There's no effect on the domain. The domain will still, because these curves still go forever. Whether we scrunch these up or spread these out, my domain doesn't change in terms of what I can plug in. So my domain is not affected. So you put none, there's no effect. Okay. They just want you to put the letters from up there. So range, D does affect it, and D, yep, up and down movement. What else affects the range? A, right, your amplitude. If your amplitude's 6, you now have from 6 to -6. I move it up 2, now it's 8 to, -4. But range is affected by A and D. Amplitude's affected by, nope, just amplitude. Just A. Amplitude's only affected by that one. Period is affected by only B. Okay, now this is interesting. What changes your zeros? So where it's crossing through the x-axis there. What's going to change your zeros? It says, so B for sure, because that's going to scrunch, right, or spread out. So that's going to change your zeros. C for sure, because you're shifting left and right. Okay, D is going to, because when you shift up, your zeros happen at different points because the curvature is going to go through a different point. And then what it says is for A if D is not 0. So if you move it off the line and then you stretch it, it will change. So A will play a part. But if D is 0 and you change your stretch, it doesn't do anything. Right? We kind of know that. If you don't move it off the line, that 0 is going to stay the same because you're stretching from 0. Okay? So that's what it's talking about there. State the max min values of the functions in terms of A, B, and C, and D, if A is greater than 0. So what this is saying essentially your max will be A plus D. Your amplitude plus your phase shift. Like if whatever that is, that's where you're going to be for your maximum. Your min will be negative A plus D. So your amplitude flipped plus whatever you do. And that D can be a negative number, right? So if your amplitude is 6, but you move down 2, it's 6 minus 2 for a max of 4. So the D can be positive or negative. All right, determine the range of the function. So what's the range of this function? So it's kind of what we just looked at. So the ranges would be the max to the min, right? So what's the max of that function? A plus D, right? So -1, that's the max. The range is -1 to 7. Nope, I wrote that backwards. Sorry, 7 here. The 1's actually the bigger number. It's negative. So bigger than -7, less than -1. Okay, all right, great job. Good.